Hello everyone, welcome back to our 100 Day Challenge and today day 6 where we are going to talk about containers and containerization. So it's all about containers today. So containers are actually revolutionizing software development and deployment because of its isolation, portability, efficiency and scalability. So from development to production, containers are driving business innovations and growth and trust me guys, right now whatever application and services you are using, most of the services are hosted on containers. So it's a new place, or we can say new technology to host your application and services after the virtual machines or cloud VMs. It's a modern days hosting platform for any application and services. So it is very important and it's in trend. If you go to over the internet, you can get it. Either you are using Netflix, you are using YouTube, or you are using Amazon or any web application you are using. Most of the new application which is modern are hosted on these containers only. So we are going to deep dive into containers concept, how the underlying technology works, and what makes it more powerful than the traditional hosting platform. So let's start. Now it's time to understand containers. Okay, so containers are a lightweight and portable solution for packaging and running your application. So that means it is the smallest unit where you can host your application. So why it's a lightweight? Because it is using only the component which is required to run your application. Why it is portable? Because it uh, it is platform independent and you can run the same containers or different platform and it will give the same outcome. It's not dependent on the platform where you are building this containers, and how it is packaged and run the applications. For example, that we will deep dive in detail. The only thing you need to understand, for example, it's a container, it will have the required binary to run your application. So if it is your application, that in the same container you will be having the libraries or the dependency which is needed for this application to run. Similarly, it will require the required files and all. So the thing is, container is one and only, we can say, the small version of VM. Everything is running. The only thing, it is using the best operating system. That we will understand how it is abstract the operating system and these all. So in today's session, we will explore the basics of containerization, popular containerization platform, and real world use cases for containers. So these are the things we are going to explore today. So let's start. Before deep diving the underlying technology of containers, let's understand how it is different than virtualization. So the thing is, if we talk about the virtual machines, here we have the comparison between virtual machines and containers. These containers can be anything like a Docker container or container D containers. There are multiple container runtime that we will talk about, which creates the containers, but here we took the example of Docker containers. So if we talk about the virtual machine, how the infrastructure is built, we have a physical server, means your physical host. In your case of VMware, it can be ESX. Okay, ESX. So on top of that, normally what happens, we have two types of concept here in virtualization. Either we can use this hypervisor directly on physical host, or we can run this hypervisor on top of our operating system. It's all depend on us. After this running this hypervisor, it help us to abstract this physical box into virtual machine. That means here these virtual machines are built out of the resources which we are having for this physical host. So here the division, or we can say the abstraction, is on the host. So we can say it's a host level abstraction, host layer abstraction, we can say. Okay. So what we do, we divide this host into chunks of VMs. And on that VM, we can run our OS, we can run our code, means libraries and dependencies what we require. And top of that, we can run our application. This is about virtualization. If we talk about the containerization, it's the same, like you can have your host machine, you can have your operating system. But here, in place of hypervisor, we use container engines. So in this case, we are having Docker engine here that help us to abstract the operating system. Means the resources what it is taking from the host operating system, not from this host. So this containers is having the ability to utilize whole resources from this host. But in VMs, we can't use it. If we give the resources, like it will use only 2 CPU, 4 gigs of RAM, and 100 gigs of data drive from this host, then it will use only that one. But here, in this case, if needed more, it can utilize the resources from this physical host. So you can understand that if your underlying infrastructure is huge, you have the more flexibility to scale, right? But there are something through which we can limit these resources, but ideally it is having the access of whole host. The only thing it's do the dividation on the host operating system which we are running. So if we talk about in one line, container abstract at the OS layer, virtualization abstract at the host layer. So this is the difference between the virtualization and container. So here, if you see, in the containers, you don't see any guest OS, right? No guest OS required. That's why there is no need to boot any operating system to run this containers. That's why it is too much fast. But on the other hand, if you want to run your virtual machine, first the operating system will run. Once it will functional properly, then only it will execute our application. But on the other hand, containers don't require these things. That's why containers are best in terms of speed, in terms of efficiency, in terms of isolation, everything. So this is the future of our modern infrastructure. So far, we have talked a lot about containers and its benefits, but let's have a clear picture in this screen itself. If we talk about the container, what exactly are these? So container is a lightweight, standalone executable package that can run your application and contains everything an application need to run it, which includes your application code, dependency, and library. So these are the things it include and help us to execute the application. Now let's understand how these containers help us as it provides isolation. So containers provide a high level of isolation and security between applications sharing the same hosting system. So that means your containers are running on the same host, but still they provide the isolation. These application can't connect to each other if we want. It's all depend how we want the connectivity. It's all about learning about containers networking. I'll talk you about the networking modes in few minutes, but for the time being, that just understand it can provide the isolation if still they are using the same host and sharing the same host for the resources. Still, they provide the isolation. Next thing, it provides the portability. Containers are designed to be portable and can run consistently. That means it's independent from every platform across any infrastructure. These infrastructure can be your physical server, virtual server, or cloud environment. Wherever you want to run these containers, it provides the same consistency while executing or running the application. Next to benefit, it provides efficiency and scalability because they use shared resources and quickly spin up or down as per needed. That means whenever we want, it can run in a second. Normally, it takes millisecond, but let's talk about in second. It can be up and it can go down whenever we want. So the disposal is also easy, provisioning is also quick. So that's why it's very efficient and scalable. Now it's time to talk about containerization concept. So the thing is, containerization works on a simple concept like build, ship, and run. So these are the three things that normally comes into containerization. First, we need to build the containers. Then it will be, as we know that it is portable, so it can be shipped wherever we want to run. And in the last, we need to execute it. So the thing is, it build once and run anywhere. So containers provide an abstraction layer between the application and the underlying infrastructure, which makes it possible to run this application in any of the environment which we already discussed, like physical, virtual, or cloud environment. So next thing about containers is containerization is the process of packaging an application and its all dependencies as a container. So once it is packaged, the container can be shipped easily to any infrastructure to run. So what it holds your application, it holds the required libraries and library, and dependencies. So it holds everything. Once it is packaged, it can ship anywhere, and then it can run on any environment. So it's like build, ship, and run concept. Guys, now let's understand containers networking. It's time to learn about how containers communicate with each other. So networking is actually an important aspect of containerization as it allows containers to communicate with each other and also with external systems. So if you want to communicate between the containers, if you want to communicate containers to your host, then also you need it. If you want to communicate containers which are hosted on different hosts, then also you need this networking. If we talk about in Docker, we are having three modes. Okay, so there are three modes. In first mode is bridge, next is host, third one is overlays. So what is the difference actually? So first one is bridge. This is the default networking mode in Docker. Here we are talking about in terms of Docker. In our next session, we are going to deep dive into Docker, but let's understand how containers actually communicate between each other if we talk an example of Docker. So this is the default networking mode as I mentioned, and in this mode, each container is assigned a unique IP that can help us to communicate with other containers on the same bridge network. If other containers are on the same bridge network, that means we it will be by default communicate. Next, we are having option of host. So in the host mode, container shares the host networking stack, which means that container uses the host IP address and network interfaces. So here, in this case, it will use its host IP address and network interface का, which can be useful for performance sensitive. So this can be useful for performance sensitive application that require direct access to the host network. So whenever you need to communicate with your host, you should use this mode. Okay, host networking mode. Next is overlay networking mode. In the overlay networking mode, you can create a virtual network. Okay, virtual network that spans multiple hosts. Okay, means this virtual network which you are creating, it should include more than one host, and so your containers from one host can communicate with other hosts easily. So here our containers are hosted on different hosts. These hosts can be anything, but we want to communicate these two containers. That's why for this case we need overlay overlay networking mode. So each networking mode here which we discussed has its own advantage and disadvantage. Okay, but networking mode you choose will always depend on your specific use case. So for example, if you want bridge mode, it's useful for application that require isolation, while host mode is required for useful for applications that require direct access. So in this case, it is communicated between one container. Here in this one, it can share the same network. So both the containers which is using this mode can communicate easily. When you are trying to communicate between different hosts container, then you need to use overlay container. So these are the different mode we are having for containers networking in terms of Docker. So now it's time to look for the different container runtimes available in the market to for better understanding. So what are actually these container runtime do? So the thing is container runtime is actually responsible for executing and so container runtime is actually responsible for executing and maintaining or managing the containers on the host. So we are having different container runtimes from different companies in the market. The most popular one you already aware about Docker that we discussed in this video. But there are multiple like container D we are having Podman, we are having BuildKit, we are having Runc, Arcati, Vagrant, Vilda. So there are many container runtimes we are having. Every tool has their own advantage and disadvantage. It's all depend on your usability, your use cases, your project, what you want to achieve. Accordingly you need to study and use that particular container runtime for your project. So these are the one which I highlighted. Just go through them and explore more. But tomorrow we are going to cover Docker in detail. So now it's time to learn about common use cases where we can use the containers. So the thing is right now, we are using microservices architecture, or we can say we are leading towards microservices architecture in all the fields rapidly. So the thing is here we are dividing our application components in multiple chunks so every team can work on individual components. So it is faster and make it easier to maintain. So it's a main use cases to use container. Next, we are using multi-cloud or hybrid cloud environment. So containers offers the ability to deploy on any platform consistently. So it's always better to use whatever suits it in terms of platform. So containers are best used for that one. Next is DevOps and CI/CD pipeline. Containers streamline the development, testing, and deployment process. So it's a make it easier and more reliable. So now earlier it was not like we were not having the stable container, but now there are many technologies which are providing stability. So the thing is now the use of containers are rapidly growing and it is helping DevOps and CI/CD pipeline as well. The next thing, the big chunks you know about data science, machine learning, big data analytics. So the thing is, containers can be used to run data science and big data analytics workload as well, with providing a portable, scalable, and isolated environment for data exploration and analysis. So these are the most common and very important, I can say, the use cases what we can use for our container or through our containers. Now let's understand the best practices for containerization what we should follow. If you are a developer, you should follow these. You should use a single process per container. That means you should avoid to run multiple processes within a same container, because the thing is, as we know that containers are immutable infrastructure, where what happens if there is something wrong with this container, actually we don't repair it, we discard it and then we run it again on a different container, the same thing similar. So that's a good that you always use one process per container, keep containers lightweight, always try to avoid heavy lifting of any containers so it will be easily portable. Next is you should define dependency explicitly. What is the purpose of using that dependency or library? Next thing, you should use environment variable whenever it is possible for your configuration. Next thing, if you are a operations guy or operator, then you should follow the least principle of least privileges. That means you should only give the permission to the required people, not all the people within your company. Next is always monitor and log container activities. That will help us if there is anything wrong so we can fix it at early stage. Ensure proper network segmentation is assigned. And the last thing, you should use secure container registries for your containers. So these are the few best practices in general we need to follow in day-to-day life or in our IT company. Now it's time to talk about some future trends going on as per Google in container technology. So it can be used in machine learning and AI. You know, the AI is rapidly growing since December 2022. From the last 10 months, if you have gone through the internet, and there are many viral videos, there are many viral tools, and the content related to AI is huge now, and the people are drastically changing their way to think and trying to utilize AI wherever it is possible. That's why we saw some hiring in different organizations, because they are still thinking where they can use and optimize their workforce. So they are planning to use this one, and containers are helping this in machine learning and AI based companies as well. Next thing, serverless computing. As we know, we are not focusing much on owning the infrastructure. We are trying to build the application which are serverless, that means which are independent to underlying infrastructure. So containers are the best in that one. The last thing it can be used, or the future trend which we can see for the container technology, is blockchain and distributed ledgers. So containers can be used to deploy and manage blockchain and distributed ledger applications, which provide a secure, portable, and resilient environment for decentralized applications. So wherever we see decentralized application or distributed, we can directly use containers for that one. So these are the future trends we can say in container technology. So guys, that's it in this video. I hope you find this video helpful and engaging and help you to learn something new related to containers and containerization. Join me tomorrow where we will deep dive into Dockers and related technologies. So keep learning, keep exploring, and keep transforming. See you in next video tomorrow. Hello everyone, welcome back to our 100-day challenge. So today is day 7 where we are going to talk about Dockers. Yesterday we have talked about containers and containerization. So what exactly we are going to talk today? We are going to talk about what exactly the Docker is, why it is so important, how it is different than the traditional virtualization. Also, we will learn about most important Docker terms that help us to understand Docker in more effective way. So without wasting time, let's get started. So, friends, before starting today's session with the Docker concepts and the other aspects, let's check the knowledge related to containerization because this is the base of our Docker, right? So, the first question we are having, what is the container in the context of software development? A physical storage unit for computer hardware, a lightweight, standalone, and executable package that includes everything which is needed to run a piece of software, a graphical user interface for managing files and folders, a type of virtual machine used for gaming. So you what you need to do, you just need to write down the answer of all five questions. I'll share the answers very soon with the explanation, but here it's about your knowledge check. So let's see how much you can make it correct. Next question we are having, what is the primary advantage of containerization? Increased hardware utilization, improved code quality, enhanced network security, or better user interface design? So this is the second question. Just write down the answer for this one. Next question we are having, which of the following is not a common use case for containerization? So I have already explained the use cases in my previous video for containerization. If you have not gone through, first go through that one. It is for microservices architecture, running legacy applications, continuous integration and continuous deployment, mobile application development. So which is not a common use case. Next question we are having, what is the purpose of a Docker file in containerizations? To run containers, to configure the host operating system, to define the instructions for building a container image, to manage container logs. So if you know the answer, just write down, otherwise you will get the answer in this video itself after going through this session. Next question we are having, which of the following is not a benefit of containerization? We have already seen the question for use cases. This is for the benefit, not get confused. So first is improved portability, reduced resource utilization, consistent development and production environment, efficient resource utilization. So these are the five questions you need to answer in the comment section. Check your knowledge, how much correct you are doing and how much you understood about the containers. If you still think that you need to learn containerization, then go to the day 6 where we talk about everything related to containerizations. Now let's talk about the first topic, what is Docker. So just understand this thing, we have already talked about the containerization, and we have also talked about the benefits of these containers. But the thing is, who will create these containers? These containers will be created by container runtime, right? So exactly, Docker is a tool, or we can say a container runtime that allow you to package and run application in a containers. Actually, containers are lightweight, self-contained unit, means which is having everything which need to be run a application independently. That include its code, runtime, system tools, and system library. Whatever this application is needed to run, it is having everything. So Docker makes it easy to deploy applications consistently across different environments. So that's why Docker is very popular in terms of container creation, container management. Is mostly it is used as a container runtime. Even in Kubernetes, we can use it. Now let's understand Docker in a single slide. So in this one slide, you will learn everything about Docker at high level. So Docker uses containerization concept, or we can say it's a tool which uses containerization or do containerization. So Docker allows application containerization, which provides a lightweight, efficient way to execute application with all their dependencies. This is just a short summary of what we discussed in our previous slide. Now let's understand what is the difference between Docker container and virtual machines. So as I already mentioned that when we are talking about the virtual machine, if you have not gone through my previous video, definitely you need to go through, especially for this one, to understand what is the main difference between the virtual machine and container, because I explained it in depth. But for higher level, a virtual machine, it's like a Means it's do hardware abstraction. On the other hand, Docker containers is about OS layer abstraction. What does that mean? When we are talking about the virtual machine, it's a divide the host physical box or hardware box into chunks, and on top of that we create the virtual machine. On the other hand, containers is like it's a having host, and top of that if you are having OS, so it's like it's a divide this operating system and uses the chunks of these resources from operating system, but it is having the capability to utilize whole hardware box. So Docker containers run directly on the host machine's OS, which means they use fewer resources than traditional virtual machines. And containers don't need to boot operating system, but on the other hand, VM machine need to boot guest operating system. So this is high level difference, but you need to understand fully. So go back and learn that thing. Benefits of containerization, if we talk about containerization, allow application portability, faster deployment time, and better scalability. And containers work on the concept of build, ship, and run. You can build these containers, then you can ship it because these are very portable in terms of transferring or moving, and then you can run it on any platform. Why we should use Docker? So actually Docker allows for consistent and portable development environment, resource efficient deployment, and easy integration with other DevOps tools. That's why Docker is very popular since 2013. So these are the high level overview of Docker. Now let's talk about images. What are Docker images, Docker files, how the images are created, how the containers are created out of that one. So we are going into deep now to understand the underlying technology. Let's talk about the very important part, because this is very important to understand when we are working in real time. Okay. So first we need to understand which platform Docker actually supports, right? So it supports Windows, Mac OS, and Linux. So all three these platform it support. Not only these, but also it supports most of the cloud platform which is available like AWS, Azure, or GCP. Also, we are having Docker Desktop and Docker Toolboxes, which are very popular installation options we are having. So these are the platform understanding where we can run our Docker, whatever system you are having out of this, you can try Docker on top of that. Now the thing is, what is the installation steps we need to follow? First, we need to verify that all the dependencies and prerequisites are followed on the platform which you are looking for. So for that one, you need to go to the Docker site and check that one. Then you can then run the platform specific installation package, just download and install it and verify the installation. How you need to verify the installation, I'll mention in this slide itself. So how you will verify? Once you have installed the Docker, you need to run few commands which will ensure that Docker is operational and working well. So you can either run Docker hello world command to test your application, or you can run Docker version command. So the command will be, you can run Docker // version. So once you will run this command, it will show you the version of Docker which is installed on your system and the build. So there is a specific name, identity of that build that you will get it. So let me show you the demo now itself, but hands-on lab we will do in our next session. For the time being, you just need to learn how to validate Docker is installed or not. So guys, once you log in and created the instance from here, now you need to check that which edition or version of Docker is installed on this machine. So how you can do that one? You can do it directly here. This is the command to check the Docker version if it is installed or not. So this is the way you can check if your machine is having correct Docker version or not. So you can check this thing. It's like 24.0.2. This is the version and this is the build. So this is how we need to check if Docker is installed or not. this command will run on any platform where you have the Docker installed. For the more labs, we will go through the next session, but today just about checking the Docker version if it is installed on your machine or not. So guys, before deep diving into other topics, first understand what are the terms you can get related to the Dockers in our coming sessions. So it will be easy to understand. First thing is we mostly talk about the Docker images. So what exactly these Docker images are? So Docker images is like a snapshot, or we can say the executable package that includes everything which need to run a piece of software, including the code, runtime binaries, and the system tools. Once you run this image, then you will get the containers. So the thing is to create containers, you need to run some image. These images can be anything like Python. It can be based on your. So there are many images. We will go through the examples as well after some time. Next thing, you need to understand what is container. We have already talked about container is a running instance of a Docker image in terms. So what exactly the containers here? It's a running instance. That means we can perform the task on this one, right? We can stop, we can start, we can pause. It's like we can perform the task on this running instance. That is our container. Next thing, then what exactly the Docker file is? So the thing is, before building image, we need to have some file. Okay, that file will have some instructions. How this instruction will be, like you need to run this one, you need to use this base image, you need to copy this thing while running the containers, and what are the ports, everything, whatever you need to specify in this image, what exactly it will perform to create the container, that instructions we need to define in our Docker file. So Docker file is a text file that contains instructions for building a Docker image. It defines the base image, application code, dependency, and the configuration setting. So Docker. So first we will create the Docker file. Here we will write the instructions in simple language that I'll show you how to write it and what types of instruction it will have. Once we will have this one, we will run the command like docker build. Once we have that run this command, then it will create the Docker image. Once we will run Docker run command, it will run this image and will create container. So it will be like first step is to create Docker file. Next need to create image or build image. On third thing is to run container. Next thing, as I mentioned, we will create the images, but where it will be stored. So it will be stored in a registry. So what exactly the registry is? Registry is a storage system for Docker images. What it will hold? It will have Docker images. So Docker Hub is a public registry where you can find and share Docker images. Private registries can also be set up for internally. If you want private, like you are in a development phase, you just want to run and test, that you can use this private registry. Okay, so we can have two types of private and public. Private is related to yourself or some individual organization, but public is open for all. Next is, then what is repository? Okay, so a repository is a collection of related Docker images with the same name but different tags. What does that mean? And it will allow you to version and organize images for different purposes. Okay, so you are working on an image that will run some Python code. Okay, first time you build it. Okay, the version of this one is V1. You want some upgrade or modify something, next version is V2. Similarly, you work on that one, then next version is V3. So these all images will hold into a repository. Okay, so this is the repository. Next term is tagging. So whatever we are defining here along with the image name, so a tag is a label or version identifier for a Docker image. So with this additional information, or we can say the metadata, these tags will define that one. It's kind of a label. Next thing, Docker daemon. Docker daemon is like a engine, we can say Docker engine, which run in a background, and it manages the Docker containers and images on a host system. So whenever we need to perform these things like building image or uh, like building image, running any image or anything related to this one, related to Docker, it will be performed by this component, that is Docker engine. So it's kind of a brain of a Docker, we can say. So whenever now let's understand last term, then we will understand the relationship of this one. Next is Docker client. So what is Docker client? Docker client is a command line interface, as we already seen when we run a command of Docker version. So it's a command line interface that allow users to interact with Docker daemon. So whatever command we will write here in the command line interface, that command line interface is Docker client, but whatever command we are running here, it will connect to this one, Docker daemon. This Docker daemon will run those commands, and or we can say execute those commands to perform some task. So whatever command you will run, it will go through like this way, and it will use API for that. So this is how, and the important terms we are having. We are having different more terms also, but we will learn about that once we will go through that particular topic. So for the timing, you need to understand what is image, what is container, what is Docker file, what is registry, what is repository, tag, Docker daemon, Docker client, because these are the most common used terms while running or learning Docker or using Docker. So guys, that's it in this video. I hope you find this video helpful and understood little bit about Docker. In next session, we are going to talk about Docker architecture, where we will understand each component of the architecture, how those components works together. We will learn about the Docker images, Docker file, Docker networking, Docker compose, how we can run multiple containers as well. So till then, keep learning, keep exploring, and keep. Hey guys, welcome back to day 8 of our 100 Days DevOps and Cloud Challenge, where we are going to talk about Docker architecture. We are going to talk about Docker architecture components, what we are having like client, engine, registry, Docker host. Also, we will talk about Docker files in detail, how we can write the Docker file and how we can create the images out of this Docker file that we can run to create containers. Along with this one, we will talk about the common use cases of Docker that you can use. And in the last, we will talk about the advanced topics related to Docker that can help you to scale up your Docker knowledge. So without wasting time, let's get started. Now it's the time to understand Docker architecture components and its workflow. So how Docker works, we will see in here. So first thing, we need to understand what are the core components any Docker is having. So normally we are having three core components. First component is Docker host, that you can see here. What it consists and what exactly it is. It's a core component of Docker which contains everything which is necessary to run and manage Docker containers. That means here there is a one component called daemon that is the brain of Docker, and it helps everything whenever it comes about the execution. Either it is building, either it is pulling the images, either it is running the images and creating containers. So everything, every task is done by this Docker daemon. So what it do? Whenever there is a pull request, it will pull images from the registry and then it will run those images. Next component, we are having Docker command, which actually interacts with the Docker engine to create, run, or do anything what is needed for the container. So it can also communicate with the remote Docker host as well across different platforms. So what exactly it is? It's a second component, client, Docker client. As if you gone through the yesterday session where we checked if Docker is installed properly or not through some command. So that command line interface you saw, that is actually the Docker client where we give the instruction or we run Docker commands. So that is our second component. Next is Docker registry. Here you can see third component, that is Docker registry, where actually our images are stored. So before running any new images, we need to pull it from registry. So this is how the Docker architecture components are divided. These are three: host, client, and registry. Let's check the workflow of Docker. So for example, you can see three components here. These are the same thing. The only thing you need to understand the dotted line. So if you want to build an image from Docker file, right, you need to run this command Docker build. So what it will do, it will go to through the API to Docker daemon. Then what it will do, it will check the images here. Okay, it will build the image here. So if it is not created, it will create here whatever image we specify in through the build command. Now let's run the Docker pull command where it need to pull it from the registry, right? So you can see this time this type of dotted line is coming from the registry. So once it will come to this Docker daemon, every command which is going from Docker client to host, it is going through the API, that is REST API. So it is going from here, and then it is pulling that image to our local system. Then only it will run. So whatever platform you are using, where it will pull this image from the registry. Next thing, Docker run command. Okay. Once we pull the images, then we can run the Docker image. So here you can see different type of Docker dotted lines are here. So what it is doing? It is running this particular image and creating the containers here. So on the same host, it will create the container and container will run on the same host. So whatever command we will put here in the client, it will first go to Docker daemon in the Docker host, and as per your command, it will check if it is need to perform from the local host itself, or it need to pull the images from the registry. So third component will come into picture whenever we need to get images or we need to push images from the Docker registry. So this is how simple we can define the Docker architecture. Now let's understand Docker images, what exactly it is. Docker images are, as I already mentioned yesterday, that these are the read-only templates which is used to create Docker containers. How we need to create Docker images, we will see in next slide. From the Docker file, each image consists of one or more read-only image layers that build upon each other to form a complete file system. If you want to create more than one layer, that you can do it within inside a Docker image itself. So it can start from a base image. Top of that, you can write down the instruction what it need to follow for the container when it will be created. If you want to copy anything, you can do it. If you want to run any particular command, that is, you can do it. You can also specify what ports need to be open to communicate with that container. So everything you can mention in the Docker file. Once you will create the Docker image from the Docker file, how we need to create that we will see definitely. Yeah. But we can define everything in a Docker file, then we can create these Docker images. So once you will run these Docker images, your container will run. Next thing, before running any Docker image, you need to pull it into your directory, okay, current directory. Then only it will run. So how you can pull it? You can use a command called Docker pull command. Even after creating, if you want to push it, you can push it to Docker registry. There you can have a public or private registry according to your need. But whenever you need to run any Docker image, first you need to pull it, then you can easily run it. Otherwise, once you will run it, first it will search in local directory. If it is not available, then it will by default check in the Docker hub registry. Next thing, as we already discussed about Docker tag as well, this command can be used to provide additional metadata such the image version or registry location. It's like a common text that is useful to understand as a human being what is about this images. So we can define that thing also. So this is how we can pull the Docker image and we can run it. Next thing, if you want to create your custom image, that also you can create it. So that is what we are going to see in our next slide, where we will create this Docker image from the Docker file, where we will use the Python base image, and top of that one, we will provide some instructions that need to be followed by the container. So you can create your own Docker image using the Docker file, which contains instruction for building an image from a base image. And which command you need to use? You need to use docker build command to building an image. If you want to run any image, you need to run docker run command. So this is how docker images are structured, and these are the few important commands which I mentioned here, like docker pull, docker tag, docker build. Commands can be used to work with docker image, and you can also run these images to create containers. So these are the useful information related to docker image. Now let's understand docker file. So what exactly this docker file is? This docker file will be used to create a docker image. So here I have given an example of this image. Here you can see few lines are written, or we can say it's a instruction in our docker file. Once we will create or build the docker image, it will follow these instructions. Okay, so let's understand what it is representing. So it will be helpful to understand while you are creating your custom image or you are using any existing image, and then you can make the changes out of that one. So here you can see first line itself, it's telling it's starting from, so which actually specify the base image which we are going to use. So here we are going to use Python, and 3.11 it's a version of this image. This is the base image. Top of this base image, what it is doing? Next instruction is talking about the work dir. What it is representing? It's representing the working directory inside the container. So in this case, we are setting the working directory to /app. Next, you can see the commands called copy. Here also, we are having two commands with the name copy. So what it is specifying? It's a instruction. So this copy instruction copies file from the host machine to the container. So where is the host machine? Here. Okay. So in this case, we are copying this requirements.txt file and the app.py file, right? Where we are copying this file? We are copying this file to from host machine to the containers. So once the container will be created, these files will be automatically copied from your host machine to that particular container. Next command you can see, it is showing run command. This run instruction runs a command inside the container. So this what it will do? It will help you to, or we can say help containers to understand which command they need to run after they create it. So here we are using install command to install the dependencies which are listed in the requirement dot text file. So first what we did exactly, first we copied this requirement dot text file to the container, then we run this pip dot install command on this requirement file because it is copied and available in the container. So now understand the last line, that is the command. So command instruction actually specify the command that will be run when the container starts. So these are the things, and it will run in sequence. So it have each line here it is mentioned, right? 1, 2, 3, 4, 5, and 6. Here we are having 6 lines, or we can say 6 instructions. So these are kind of a layer for our Docker images. So once the Docker file is created, you can build the image using this following command. So what we need to do? First, we need to write these instructions, create the Docker file, save this Docker file with YAML extension or .yaml, whatever you want to choose, you can do it. Once it is created, then you can run a Docker build command. What is Docker build command? Build command. For example, we are going to save this image like my app. Then we need to define the name of that one. So this is the thing, and we want to save it in our local directory. Okay. So this is how we need to run this command. Actually, we will see in our hands-on how it will be created from a Docker file. So what it will do? It will create a image called my app. Now, what we did, we took the base image as a Python 3.11. After that, we want that after this one, it need to execute these all things inside the container. So, image is something which is having all the dependency and require library along with the application information. That's why we keep everything in a Docker image. Now, after this one, what it is doing, we need to we created the image, and now our image will be my app. If you will search, it will show you your image there, available image. Now you can run this image. So for running this image, you need to run the command like docker run. In an interactive way, you need to run. Then you need to use it, and then you need to specify the image name. So to run image, you need to run this command. To build image from Docker file, you need to run this command. Once you will run this command, your container will be created. So this is the steps what we need to follow from our instruction to run a container. So first thing, we need to build, then we need to run. Now it's time to understand some Docker advanced topic that you need to consider if you want to skill up in the Docker domain. So the first topic is networking. So Docker container can communicate with each other using the Docker networking, and we are having three different mode to define this Docker networking, how the containers will communicate if they are on the same host or on the different host, or if they want to communicate with the host. So I have explained in day 6. If you have not gone through that one, then please go through that one. So day 6 video where it's all about container and containerization. So there I explained in detail all three modes. Next advanced topic we are having volume. So Docker volume is used to share data between the containers. So it's to talk about the persistent data. So the thing is, you need to learn this thing if you want to skill up your Docker knowledge. If you want, just mention in the comment section. So I'll take another session on this one, the advanced topic. Next advanced topic is security, where it provides a number of features to secure your containers. So for the isolation, it uses namespaces. So we have the option to isolate our environment, and not only for the host level, but also we can isolate at the user basis, like we are having user profile in our Windows machines, right? Similarly, we can have the same in Dockers as well. Next, some mode. Some mode is a clustering feature like we are having in Kubernetes. It's a container orchestration platform. It's provided by Docker itself, but there is some limitation with the Docker Swarm that we will see when we will start our Kubernetes session. So we will talk about different container orchestration platform. So at that point of time, we will talk about in detail about this Docker Swarm mode. So for the timing, it's another platform like container orchestration, but it is provided by Docker. Kubernetes is our open source, and it's a container. Sorry for the mistakes here for the type of container orchestration. So these are the things. Next topic is Kubernetes that we will talk in detail because DevOps main important tool right now is Kubernetes, and containers are managed by this platform. So it's a open source container orchestration platform that can be used to manage Docker containers as well at scale. So these are the advanced topic we are having that we should learn to scale up our Docker knowledge. Now, let's talk about some use cases. As you know, Docker is a powerful tool that can be used to simplify the development, deployment, and management of your application through container. So, what else we can do? We can use Docker to package and deploy a web application. So, we can package and deploy our web application. Next use cases is you can use Docker to create a development environment that is consistent across different developers. As we mentioned, that containers provide the consistent environment and are able to run on any platform. So this is the best use case we can say. Next use case is you can use Docker to deploy a microservices architecture. If you have gone through the container session, I have explained these are the famous or most common use cases of containers. Next use cases is you can use Docker to run a containerized application on the clouds. Yes, you can use Docker to run containers on the cloud platform. Whatever cloud you are using, you can use Docker. So these are the use cases of Docker. So guys, that's it in this video. Thanks for watching. In this video, we learned about components of Docker architecture. We learned about Docker client, engine, and Docker registry. Also, we learned about Docker files, containers, and how the images are created. So I hope this video was helpful. And if you have any question, then leave a comment below. And don't forget to subscribe this channel for more Docker tutorials and other DevOps tool content and join this 100-day challenge if not yet started. So start from day one. And today we finished day 8. Thank you very much for your support. So see you tomorrow. Hey guys, welcome back to our 100-day challenge. Today is day 9 where we are going to talk about important part of Docker, where we are going to refresh our Docker engine concept. We will talk about the Docker file, how it will look like, and then we have divided into multiple sections. Like in the first section, we will talk about the platform where we are going to execute our Docker command, and also you can use this pre-built Docker platform to practice your labs and all. And then I'll show you how the Docker Hub repository and registry look like, how the images are there, how the tags are defined in the images, so we can use different tags images. Then I'll share the link of the documents which can be very much helpful in Docker learning. Then we will go to the hands-on where we will execute some command. We will pull the image from the library and we will check how the images will look like in the Docker platform. So let's start now. So guys, before diving into the labs, just quickly have two slides what exactly the Docker engine do, and we will talk about the Docker files. So yesterday we had talked more about the theoretical part, but now you will have the quick representation of Docker engine, what exactly it do and how the components are related. So you can see Docker daemon are here, then there is Docker client, right, where we write the command. So this to connect the two things, we have REST API. And what exactly this Docker engine do, it manages network, containers, image, and data values. So whatever required for our container, it will be done by this Docker engine. Next thing, let's have a look on Dockerfile again, how it will look like in real time. So it's like we have already discussed this thing, like base image we can define in the from, then work directory where we need to work. Actually, we need to set the working directory, then we can copy the files from your host machine to your current location. Then we can run the or install anything with what we want. Then we can also expose the application on the port number which can be specified. After executing, we can run some command also once the container is start. So run the specified command within the container, and we can also copy anything from the source code, means from your host machine to your image file system. So these are just to have look about the Docker file, how it will look like. We will do this in demo as well. So guys, to access the platform where we will practice our Docker commands, so what you need to do, you need to just type play with Docker in the Google search box. You will find these list of website, but on the top of one you will see labs.playwithdocker.com. You need to play here. So once you will come to this page, you will not see this start option, you will see the login option, and the sign up option will come on the top. So if you are not having any Docker account, you just click on sign up button. You will say you will just need to provide your email address, username, and password. Once you will provide, you will see a confirmation email in your mailbox. How this email will look like? The email will look like this. You can see here you need to click on verify email address. Once you will click on this one,
then you will receive this email where it is mentioned what you will get it inside this Docker account. You will have all the documentation, lab guides, everything you will get it here. Once you will click on documentation, so there are two websites which is more important to learn Docker. One is docs.docker.com. Here you will see all the documentation available, even whatever tools you want to use Docker, you will get it. Okay, next thing is very important, hub.docker.com. Why it is important? Because it's a registry, Docker registry or Docker hub we can say, where our repository will be stored. From here only all the images will be pulled, or you can push your images here. Here you can create two types of library, means repository, where you can put your images. So for example, Nginx, MongoDB, you can see multiple repositories here, right? You can create your own as well. Once you will click on Nginx, you can see here it is about this Nginx, but you might be, if you are using first time, it's really tough for you. But the thing is, the most important part what we have discussed, the tags here, right? So here you can see this latest tag will always pull the latest image from that repository. See, for the same image you are having different version, you can see with the tags name, right? And every image will have a unique ID that we will see while we will run the command. But to pulling the image, you need to run this command, docker pull nginx latest, then you will get this image. If you will run this command, pull nginx stable perl, then you will get this image. So this is how tags differentiate the different version of Docker image. So now what is our next task? You need to understand. Next, you need to come to this page. Okay, once you log in, you confirm everything is set up, you just need to click here. This is the platform which we use, okay, for our lab session. So once you will click on start, you will come here. Here you will see the 4 hours time window. So one session is for 4 hours. You can use it multiple times, but after 4 hours it will be closed. You can initiate another session. Next thing you need to understand, here you have the instances. Instances are nothing like a virtual machine, you can say. On top of that one, this Docker is already installed. So we are not, if you want to learn from scratch how to install Docker and all, you can go directly here. You can click on download this one. Whatever platform you are having, Mac, Windows or Linux, you can use this one. So that's why I mentioned docs.docker.com and hub.docker.com. These two are very important websites for your Docker learning. Now you will come here, right? Let's just for the timing, we are just checking if Docker is installed properly or not. That we already checked it. If you initiate this one, you will see there is node 1. Node 1 is your VM IP address is this one. Memory utilization 4 gigs of RAM it is having, and it CPU utilization is 0.75, 0.68. It's a, you no need to worry about these parts. You just need to think about this one. Even they are providing editor as well, so I never used it. I did not need it because I always do all the things in my this box itself. So let's understand if the Docker is installed properly or not. So what command we need to run? Docker -- version. Okay, so now it is saying that we are having Docker version 24.0.2 and the build of this one is this one. Okay, so this is how we can check it, but now we need to understand the version. Okay, so which version it is using. So let's go to Google and ask Docker versions available. Okay, once you will click on this one, you will see the release notes. So we are using Docker engine, right? So right now the latest version is available 24.0.6, but this tool or platform we are using here, this version is installed, pre-installed on this one. So whatever commands are there, up to here it will work fine. Although there are same command, the only thing in the updated version, if there is few bugs, it will be fixed in the next version. That's it. That is the only difference. Now we will see. Let me clear the screen. Now let's see what are the images we are having. Okay, so for that one but the thing is, how I'll get to know if I'm not aware about the commands, right? Let me make it very simple. You just need to type docker -- help. Once you will do that one, you will see all the commands available with the Docker. So first command is like for common command like running an image. PS will help us to list the containers which are running. Images will list down the images whatever we have in local system, means here I'm talking about. Similarly, you can log in, log out from the registry. Here the registry is Docker Hub. Okay. Similarly, you can push the images from the registry, and also you can manage containers as well, like manage containers. So Docker containers you need to put, and then your command We are having different other commands also. We will learn those one by one. Okay, so it's better you just more you practice, more you will learn. So let's run the command docker images ls. Okay, now you can see I saw the attribute like repository tag image id created and size, but there is no image here, right? So let's pull some image. We have seen something like engines, right, from the docker hub registry. So let's pull that image, but sorry, I did not provided the correct command. So for this one I need to write docker pull engines, but the thing is by default it will what I can say, by default it will pull the latest one, but the thing is there is some error because with this num it is not aware, the spelling is wrong also. This is the correct spelling, and let me put you latest. If I want different image version, then I can put the tag for that one. Once I'll put that command docker pull, it will pulling the image from the registry. Once it will pull the registry, pull the image from the registry, I am able to run this particular command. But before that one, let's clear the screen and check if the images are available now or not. Okay, so images ls. Oh, there is something wrong with my command or something. Yes, it's like docker image ls is the command for this one. So the thing is you need to go through all different commands which I showed you the imported command. Just go through that one and you can explore more and more command. You will be comfortable. So here once you can see the image detail, it's a engines latest version, image id is this one, it is created 47 hours ago. How I'll get to know about this thing? Okay, that's a very important thing, right? So here if you will see, here it is the last post is 22 days ago, 2 days 48 hours, so it's like showing 47 hours. So from here also we can understand. Now let's pull some other image. Okay, this time I don't want this latest version, I want this one, stable pearl. So let me put stable pearl. If I pull this one, will my image will be updated or means override, or we will have two different images? Let's see. Okay, so I just cleared it, docker image ls, and now I can see I have two different version of engines image and I can use any one of them. Now our task is to build the image from the docker file. So first we need to create docker file. Let me clear the screen.
So guys, that's it in this video. For this time I'm going to assign a task for you. Like I have shared how to access your Docker platform. You can just go to this page. The link I'll share in the description box and also in the comment section. Here you will see different commands are available for Docker. You just need to try to execute yourself how much you can understand and how much you can do the practice. So the thing is, in the next session we will talk about more on the Docker file to container creation. So that we will do, but before that one, just have a practice so it will be easy for you to understand. So see you next video or next session tomorrow. Till then, bye bye. Hey guys, welcome you all in this 100-day challenge, and today is day 10. We are going to cover container orchestration today. So we will start from very basic. If you not know anything about containers, don't worry. We are going to start from the scratch, and then we will talk about the benefits and the key features what container orchestration provide and why it is more important to learn as part of DevOps journey. Then we will go through the important tools and then we will summarize them in one liners that will help you in your interviews. And in the last, we will compare these all tools together. Let's start without wasting time. So, guys, let's start what exactly the container orchestration is. So, in this video, let's try to understand from the very basic. Just imagine orchestration as a conductor of a music band who decide when to start, when to stop, or if there is any change in the tempo need to be done. So that conductor decide everything, right? Similarly, in container orchestration, this orchestration behaves like a conductor who decides when container need to start, container need to stop, or if there is any change in the configuration, like if they need to scale up or scale down. Everything is decided by this container orchestration. So what it do? It's a it involves managing the life cycle of containers, including provisioning means creation, deployment, scheduling, scaling, or networking. Everything related to the container management, it need to be done by this orchestration. So if you remember last in our previous session, we have talked about container and containerization. Then how it is different than this container orchestrations? For example, initially what happened? We had the container. So whatever resources, whatever management of the resources related to this container is done by container, container runtime, right? That is in our case it was Docker. So this container runtime manage everything like networking, data, or any component of this container is done by this container orchestration. Means the resources of the container. But what this container orchestration do? It manages container itself, when this container need to create, when this container need to scale up, when it need to be destroyed. Everything need to be managed by this orchestration. Not only this thing, it also schedule, it also manage the containers networking. So many things can be done by this container. So why it is importance? Because it enables the efficient management of large scale containerized applications. So it can manage thousands of containers together, improve the resource utilization, and also enhance scalability and fault tolerance. What does that means? That if one container is not working, it immediately destroy that container and launch new container. So if we define this container orchestration is a process of managing containers life cycle. Either it's a deployment, either it's a provisioning, scheduling, scaling, or networking. Everything is done by this container orchestration. Now let's quickly understand key concept in container orchestration. Although we are having like hundreds of concept in container orchestration itself, like Kubernetes, but here are the main key concepts that will come again and again. Like first is containerization, which we already discussed, that it package application and their dependency into a lightweight and portable container. If we talk about orchestration, that we just gone through, like it's a managing the life cycle and interaction of containers using the automation and control system. Next thing, so what is scheduling? Scheduling is like assigning containers to resource based on requirements and availability. It identify the best suitable nodes. On top of that, it can schedule the container. Next is service discovery. It's like tracking and discovering containerized services within the cluster itself. So we can have multiple nodes within the cluster, right? Who will decide that this container should run on this host or something like that? We don't define the nodes directly. Sometimes it's like a huge environment. We don't know how many nodes are there. We just run the command that container should deploy, but on which node it will deploy, it will do everything. So container orchestration is not just about managing the container's life cycle, but also about so many different surroundings like tracking, discovering, assigning, scheduling, controlling. Everything is done by this container orchestration only. That's why it's more important to learn. Now let's talk about why we need container orchestration. As we already understood, like it provide efficient resource utilization, scalability, and high availability and fault tolerance. Also, it do application update and rollback. It can do the update and rollback. Also, it can help us to run multi-container application and coordinate them efficiently. So there are huge benefits we are having our container orchestration. That's why we are learning this concept before going through the tools. So once you understood this container orchestration concept, then definitely it will be easy when you will go through any tool, either Kubernetes, OpenShift, Rancher. There are many. We are going to talk about 10 container orchestration tools in tomorrow's session, but today we are going to cover some important tools out of them. So now we understood that what is container, containerization, or container orchestration. But in real world, what we will going to use it, right? How we will use it. So there are different tools available which uses this container orchestration concept. So the most popular, Kubernetes,
we are having Docker Swarm, we are having Apache Mesos, and we are having Red Hat OpenShift. So here I'm just in today's session I'm going to cover these four in short, but tomorrow we are going to talk about 10 different container orchestration tools. So if we talk about Kubernetes, it's an open source platform for automating deployment, scaling, and management of containerized applications. If we talk about Docker Swarm, it's best for Docker containers. So it's a native clustering and scheduling solution for Docker containers, which allow easy scaling and management. Next tool we are having Apache Mesos. That's an open source distributed system kernel that provides efficient resource isolation and sharing across distributed application. If we talk about in short about Red Hat OpenShift, it's an enterprise ready container platform built on Kubernetes for managing and scaling applications. So these are just a short summary for the timing, but we will go through these tools in details. Now let's summarize these container orchestration tools which we gone through, and here are the highlighted keywords that it will help you to remember, and also we are going to talk about some supported platform for these tools. So first tool we are having Kubernetes, that is robust and highly scalable, and it supports multi-cloud and we can use it on premises as well. If we talk about Docker Swarm, simple and easy to use, but it's like single host, simple Swarm method it uses. If we talk about Apache Mesos, it's a efficient resource utilization and it also supports multi-cloud and on-premises. Next, Red Hat OpenShift, it's an enterprise features and support, and it is also multi-cloud and on-premises. So if somebody asks, you can tell the tool's name which supports multiple cloud like Azure, AWS, or GCP. You can name Kubernetes, OpenShift, or Apache Mesos. But it's good for who is using Red Hat technologies much. So Red Hat is good for them. Similarly, we will go through in detail for each tool. Don't worry. So now let's compare these tools what we discussed. So in one line, how we can define the Kubernetes is highly scalable and widely adopted. So if you see, most of the organization are using Kubernetes and adopting very fast. If we talk about Docker Swarm, as I mentioned, it's a simple and easy to use, but it's good for who are using Docker container. Next is Apache Mesos, which offers efficient resource utilization. If you are looking for that purpose, then you should go for Apache Mesos. Next is OpenShift, which provides enterprise support and good for who is using Red Hat technologies. There are few tools as well where you no need to work in a command line phase. So that also we will discuss. If you are not comfortable with command line interface, we are having one container orchestration tool for that as well, that we will discuss tomorrow when we will discuss 10 different container orchestration tools. So guys, that's it in this video. I hope you find something new in this video, learn something new. If you find it, then don't forget to click on like button, share with your friends, subscribe this channel to join this 100 days challenge. So tomorrow we will cover more key concept that is required to work with the container orchestration tools like Kubernetes, and also we will go through these all 10 tools what I mentioned. So join me tomorrow. Till then, keep learning, keep exploring, keep transforming yourself.